In this example, I wanted to talk you through how to graph the function f of x equals -4 to the x plus 3. Now, in all the problems of this type, it's best to start by graphing your parent function, which is always going to be a function of the form y equals b to the x, where your base should match the base given in the problem. So in this case, we want to start by graphing the parent function y equals 4 to the x. And you can get that on your page quickly by thinking of those three key features that I mentioned in the previous video, which are 2 points, the point 0, 1, the point 1, comma, whatever your base is, so in this case 4, and then the horizontal asymptote at y equals 0. So if we graph those features, 0, 0, 1, 1, 4, and horizontal asymptote at y equals 0. And now I would do the best to, graph what we know the exponential curve looks like, so something like this. Okay, so this is the graph of 4 to the x. Now we need to consider what transformations need to occur to turn that graph of y equals 4 to the x into the graph of -4 to the x plus 3. So identifying the transformations, that plus 3, which is outside of the exponential function, it's a plus 3 kind of after the fact. That's a vertical shift, up 3 units. The negative in front here is a reflection. And again, since the negative is outside of the function, it's not up in the exponent, that's a vertical reflection, so it's across the x-axis. Over x-axis. Now when you perform these transformations, vertical shifts, so like this one up 3, should always go last. So I'm going to do that second. I'm going to do the reflection over the x-axis first. Now we can apply those transformations to the 3 key features that I drew on that graph of 4 to the x. I'm going to start with the asymptote, which originally was y equals 0. Now when I reflect this asymptote over the x-axis, it's on the x-axis, so that's not going to go anywhere. But then we shift the whole thing up 3. And so now the, and I think I said vertical asymptote, I'm sorry if I did, horizontal asymptote is here. And again, it's nice to label it. So now it's y equals 3. It was y equals 0, it shifted up 3, so now it's y equals 3. Now I'm going to move the 2 points. So starting with this point at 0, 1. If I reflect it over the x-axis, that's going to flip this down to -1. And reflect it this way to -1. And then from there, go up 3. 1, 2, 3. So I'm going to land here at 0, 2. I'll plot the point here. Okay, transforming the second point that was originally at 1, 4, because the base is 4. Reflect that over the x-axis, and I'm going to be off the screen here. Oh, shoot. And I do that to myself all the time. Should have caught that, sorry. But we can make it work here. Let's extend the axis down here. -2, -3. Let's say this is -4 right here. So we have this point here. We reflect it over the x-axis, so that's going to flip it down here to -4. And then from there, shift up 3. So 1, 2, 3. It's going to land at -1 here. So x-coordinate is 1, y-coordinate is -1. I'll plot that point here. And then with those 2 points, the asymptote, and then we know the basic shape for an exponential function with base 4, it looks something like this. We can get a decent sketch of our graph of y equals -4 to the x plus 3. If you're asked to specify domain and range on a problem like this, domain for any exponential function, it's always all real numbers. Well, unless you've got something crazy like 4 to the square root of x or something like that. But generally, the domain is all real numbers. The range, so if we write down the range, we want to think lowest y to highest y. The lowest y value covered on this graph, well, it's diving down to -infinity here. So bottom of the range is -infinity, up to highest y value, it gets very close to 3 but doesn't quite touch it. And so the range is negative infinity up to 3 with a parentheses. We don't want to include 3 in the range. There is no point on the graph where y is 3. It just gets very, very close to that.